Hi there. Today we're looking at doing a scatter plot in Desmos and some of the information that we can get out of that scatter plot. So I'm going to start by going over to my spreadsheet. I'm using Google Sheets, but you could use anything. And I'm going to highlight the data that I want to use. So it is women's height versus shoe size. And I'm going to copy that. And then I'm going to take it over to the Desmos and I'm going to paste it. And it'll just paste right in there. Okay, now this is how you make your scatter plot. Now what we can do with that is I can test different functions on it. So to me, it looks like it's probably linear. So I'm going to put in a linear function. Remember, y equals mx plus b. Remember that from good old 8th grade and Algebra 1. Looks a little bit different. So it's going to be y1, referencing the y1 from the table. And then you're going to do a tilde. So you're telling the program, hey, try this function. And then mx1 plus b. So notice it's very similar to y equals mx plus b. And now it's telling you all sorts of interesting stuff. So we have here, first of all, it's telling you the correlation coefficient right here. So let me this is the correlation coefficient. It tells you how well correlated your model is to your data. So it's a 0.64, so it's moderately strong correlation. Then we have R squared right here. And the 0.41, we're going to round to 41%. It tells you that 41% of the response variables variation can be explained by the linear model. So the linear model of the height to the shoe size explains the data about 41%. So again, moderate correlation. Then we have what you would make the equation out of. So you would go y equals, and then I'm going to round m to 0.14x plus b. I'm going to round it to 15.4. So what this tells us is a person with a height of 0, and this was female with a height of 0 has a shoe size of about 15.4. That doesn't make any sense at all, but it is where this line is going to cross the y-axis. And it also tells us that for every centimeter in height that a woman goes up, her shoe size goes up about 0.14. So that's about a sixth. So it takes about 6 centimeters or a seventh, 7 centimeters, 6 or 7 centimeters for a woman to gain 1 shoe size. And then finally, we have the residuals. The residuals are right here. So if I click on that plot, it'll put a third column in the table for me for the residuals, and it also plots them. Now I can't see them because it plots it down at y equals 0, and we're up at y equals 32 right here. So I'm going to shrink this down to where I can see it. Oh, there they are. So I can shrink this, and I can widen this so I can see it all. There you go. So our residuals are very scattered. There's no clear pattern of the residuals around the x-axis. So that tells us that a linear model works. That is a good fit, a good model for our data. The other thing we can look at then is we can also look at, this third column of E, and the standard deviation, or the S, is something that's very interesting as well. So if you just type in STGEV and then tell it E1 and enter, it will give you the S for this data. So this is the standard deviation of the residuals, which is 1.03 about. So it looks like our typical error is about 1 size. So if we're going to be off, we're typically off around 1 size, either one size too big or one size too little. So we put in the height, we predict what the shoe size is going to be. We're typically off by about one size. There you have it. Thank you.